The UN's projecting that by the year 2050 there's another 3.2 billion people moving to urban centres around the world. 3.2 billion people moving to urban centres in the next 32 years. We need something like 1,100 buildings per day for the next 32 years to be delivered just to meet the residential demand. So in our sector that's pretty exciting because we're all guaranteed work, right? In fact the number's much higher than that because that's residential, so what about all the civic amenity that needs to come along with that, the office spaces, the retail, etc. So you can get excited about that opportunity and then you can get yourself a little bit depressed about some of these numbers, and these are not new numbers, they've been around in the industry for probably the last 10 years and we should all be aware of them. But our sector, our industry, we are responsible for consuming 30% of the world's resources, which is a pretty staggering volume if you stop and pause on that for a moment. Even worse, we consume 40% of the world's global energy and we're responsible for 40% of the greenhouse gas emissions on the planet, despite what Mr. Trump might say about the realities of greenhouse gases. And we're probably lucky that the auto industry's been a fantastic scapegoat because they've copped all the blame for the last 60 or 70 years for what's happening with pollution and consumption of energy, but we're actually the culprits. We've been the big silent culprits for quite some time and we're in the business of outing ourselves right now. And the numbers get a little bit more gloomy because depending on who you listen to, we have an inefficiency in our industry somewhere around 40%. And it says estimated because I think, as per your topic of conversation earlier today, there isn't a good metric. There isn't a metric at all really talking about how efficient or otherwise our industry is. So some of the smarter consultants latching onto this think it's about 40%, and then there's think tanks writing papers saying no, we're the most productive industry there is, we're 4 times more productive than the American construction industry, and we actually outbox things like the car industry and the electronics industries, which I think for those of you who work in the industry know is complete garbage. The numbers I prefer to look at, manufacturing has had an increase in productivity since World War II of approximately 1,600%, a lot of that driven by the lean movement in the 1960s and onwards. And our industry had a peak in productivity, I would estimate somewhere in the 1960s, and then has been either flat, if you're an optimist, ever since, or actually somewhat in decline. And my personal benchmark on that would be joining Civil and Civic, Lend-Lease's building company 25 years ago. Our benchmark for any high-rise building was a floor constructed in 5 days. The same type of building today would take 8 days for a floor cycle. And people will point to safety requirements as being the differentiator in those programs, but I don't think that's the case at all, and I don't think safety should ever be an excuse on productivity. So that's enough with the numbers. What are we doing about it? Where are we headed? You've had an interesting conversation, I gathered this morning, about technology and digital, and it's on everyone's lips. And of course manufacturing is talking about Industry 4.0. And the fascinating thing about Industry 4.0 from my perspective is our industry managed to skip the first 3 industrial revolutions altogether. So you either look at that and say, well, isn't that an overwhelming challenge? How are we going to go from a standing start all the way to Industry 4.0? Or you say, no, it's an incredible opportunity because we get to leapfrog what so many other industries have painfully worked through in the last 200 years. And no one's yet challenged me on the fact that we've skipped those 3 industrial revolutions. It seems to be pretty much taken for granted, but if you're any doubt about it, think about it. We're a skills-based, cottage-scale industry, yet we're worth $10 trillion globally, which is a very strange mismatch between the scale of the opportunity and how we actually do the work. So what is Industry 4.0? If you're in the construction sector, maybe you haven't heard much about this. Thematically, it's about moving from the digital revolution we've been going through for the last 50 years and gearing it up to the next level. So it's about robotics, 3D printing, the Internet of Things. AI is hugely topical, whether it's absolutely real or whether it's largely nascent or in fact trickery in some cases, and the use of big data. So very exciting things that are happening, particularly in other sectors. What does it really look like in our sector? Well, this afternoon I'm going to talk a little bit about what Lend-Lease is doing, particularly around timber structures, because it's something that's real and it's no longer confidential, we can talk about it. But what I do want to stress is for us as an industry to move towards something that's industrialised, that looks anything like Industry 4.0, there is no silver bullet. In fact, I think what we're going to see is a combination of a number of different things to take us forward as an industry. A lot of believers in BIM and the power that BIM holds for the industry and how it will connect up silos and will get data across one part of the industry to another. And that's all true, but again, it's a necessary but insufficient condition to actually change our industry. Lean, I think, is incredibly important. If we look at the transformation that it drove through main manufacturing industries, it's got the potential to do the same thing for our industry. If I have a look at Lend-Lease and what we're doing around lean, we have a handful of experts. We have a tiny little division based in our head office in downtown, and that small group of people gets to wander around a select number of projects and apply some improvements almost on an ad hoc basis. That's not even close to what the manufacturing sector's done with the use of lean. Off-site, I have this conversation with some of the academics I work with, some of the other industry partners we work with. The time has been right for off-site for the last 150 years. The conditions are right. We're always convinced it's coming. I actually do believe it is now coming, that there's changes in technology, there's a weight of things driving us towards off-site, and I make that comment not solely about the Australian industry, but we do a lot of work in the UK, a lot of work in the US and in Asia. And so we're seeing an absolute groundswell of investment into off-site technologies. So who's familiar with the concept of DFMA? Okay, it's not bad, there's a few people in the room. So design for manufacture and assembly. So that's about understanding how something is made as you're designing it. So you incorporate in the design the good principles of how it will be manufactured. What's the machinery? What are the materials? What are the constraints on those materials and that production method? What's the capacities of the factories? What do the supply chains look like? And then taking it to the next level and saying, what's the most efficient way to make this assembly? What's the fewest number of parts? What's the least number of human interventions to assemble it? And this has come very much out of car manufacturing, and then other industries have followed suit. And some of our competitors are quite focused on this, and I think rightfully so. And again, we're growing a skill set around DFMA. But try going to a university and hiring an architect or an engineer who's got DFMA qualifications. There's no such thing, right? So there's a lot of opportunity here to build a new skill base and to transfer some skills from some other industries. Supply chain integration, I think it's interesting that the answer for competitive supply is always let's run a tender, let's find 5 or 6 parties. They're the same 5 or 6 parties we tended to in the last job. We'll send them 4,000 pages, tell them where to spot the scope and all of that, hope they got it right, and that's a competitive supply arrangement that serves our industry. If you have a look at, again, sorry to keep bringing it up as an example, but the automotive industry, how do they do it? They have long-term relationships with their supply chain and they're quite integrated. And the way it works is if GM wants a bumper on a car, it will say to its supply chain, here's what the bumper must look like. And here's the performance spec for this bumper. Now we're not going to tell you how to make it because you're the expert bumper manufacturer, but it will cost $175.25. And we're giving you a 10-year supply of them, and we want 100,000 in year 1 and 200,000 in year 2. And in year 2, the price is going down 5%. And in year 3, it's going down 5% more. And so what's going on there? Are they just putting the squeeze on their supply chain? Are they just making it hard to be in business with GM? They're actually offering up a guaranteed volume of work on the basis that the supply chain can use that volume of work to actually undertake R&D, which is a concept almost entirely missing from our industry, R&D. So supply chain carrying R&D because they've got a different way of engaging with the proponent. And digital, I gather you've covered digital in some length earlier today, so I'll touch on it briefly and what we're talking about. Is turning everything digital going to be the quick fix? No, it's going to be a challenge, it's going to drive new opportunities, it's going to bring new problems, but it is part of the suite of things that are going to have to be brought to bear on the challenge. Design automation. So there's a lot of hot air about what's happening in the construction industry. Will workers be replaced by robotics? There's certainly some fascinating robotic investments happening around the world at the moment. There's some crazy ones. I've got a strong personal view on the nonsense of having a machine lay bricks. But the reality is where we're going to see automation and robotics first won't be on the construction site. It's very much going to be in the design office and then very much in the construction management and project management offices. And you see it already now. We have the capacity in the software that we use today. So every graduate of every design school around the world is very familiar with the generative or parametric tools like Grasshopper and Rhino. And so they're using those tools to automate design processes. And the simple example I give here, mainly for our execs who don't understand how this stuff works, is take something really prosaic like a fire stair. And there's fire stairs in this building, right? There's fire stairs in almost every building. And what we do, project after project, is we pay someone to design a fire stair. And as a former architect, I couldn't think of a task that's sort of less entertaining. Let's design another fire stair. What value are we going to add to that process? So perhaps instead we automate that process, and we've done this, and you let the fire stair be generated using these tools via script, and you can do three things, right? You can let the geometry be a function of just a couple of points in the design, so solve all that, what's the rise and the going and everything else to meet the code. And the second thing is you can take the building code and you can recreate that as a series of algorithms and say, I'm not going to design something that doesn't meet the code, because as it's generated, it automatically meets the code. And if that sounds like a pretty obvious thing, well, I've been on the completion end of a number of projects and the building inspectors turned up and said, yeah, you've got a problem with this fire stair, the handrail, the pitch, the whatever detail, and in the very 11th hour of a project, someone's scrambling around trying to fix this most prosaic part of a building, the code compliance of a fire stair. But where it gets more interesting is this third point up here, that if you're using computers to do this kind of design, you can also run performance through them as well. So imagine a self-designed fire stair that calculated the number of people that's in the building and therefore how many people had to escape in the event of an emergency. So we're not only having something that's defined geometrically and legally, it's actually going to do the job it's intended to do. And this is not science fiction, this is all accessible using today's tools with people that are employed in the industry today. Whether the construction industry is actually using these tools is another matter. So off-site, and we could spend the rest of the day talking about off-site, it's another favourite topic of mine. The question I think with off-site is, what are you really doing? Are you simply shifting construction off the construction site into a shed, or are you using capital somehow to displace labour, i.e. you're moving to more of a manufacturing context? And Lend-Lease has had the experience of doing both of those. So we set up a manufacturing business in Brisbane to manufacture bathroom pods. And like all of these things, it started off a little bit rocky. The first few pods weren't so great, but by the time we'd made 4,000 of them, we were pretty darn slick at making bathroom pods. And our construction guys love them because they turn up, they're defect-free, they're ready to go, plug in the services, and lo and behold, you've got a complete bathroom. But if you actually look at what we were doing there, it was nothing more intelligent than shifting construction trades to a big shed in Brisbane. And then when you examine the economics of it, you draw breath pretty quickly, because you say, well, we had to rent a shed and we had to transport all the stuff from that shed to whatever the project was in Melbourne or Perth or Sydney, and then we had to go through all these other hurdles about how things are connected and moved around job sites and how they're inspected by building officials, etc. And in fact, it's costing us one hang of a lot more to make a bathroom that way than if we built it conventionally on site. So then you get the cost planners telling you should be building them conventionally on site. Doesn't sound like a win. What's missing from the equation, because it's hard to get your hands on, is the data about what economy was generated by not having all those defects on the project. Intuitively we know it's highly advantageous, but we haven't actually got our information at hand. What I am in favour is not that approach, but our other approach to say, well, how do we set up the fabrication of material in a way that we are using capital to displace labour, that there is something intelligent about it? Are we using more intelligent materials? Are we using a more intelligent process? Are we bringing in some form of robotics or some other process that actually means that we're reducing the cost of the fabric that we're creating in the facility? And that's what we've been doing and I want to talk about for the rest of this session. Before we get to that though, this idea that we're going to prefabricate things, in the 20th century, that's been about mass production. And mass production has probably led us into a pretty ugly space. And what we've had is some strange things around standardisation. So what I'm talking to our people internally about is, let's drop that word. Let's get away from standardisation, because it's actually not that relevant to us anymore. What we need is systemisation, not standardisation. We need parts that can be combined in a multitude of different ways, because the buildings we want to create should be contextual to the place that they're going to sit in. So I don't need a standard design. In fact, a standard design won't work. I need a systemic way of picking up and combining parts that are pre-engineered, pre-made, that I don't need to solve at first principles. And just to reference a more famous architect, Walter Gropius, as long ago as 1964, making this comment here, and it's part of a much longer quote which is really worth reading at some stage, that prefabrication was seized upon by certain manufacturers who came up with the stifling project of mass producing whole house types. instead of component parts only. And of course, if someone says manufactured building, that's exactly what comes to your mind when you first think of it. You think about tract homes, project homes, horrific repetition, architecture completely denied, urban placemaking completely denied, and it's obviously driven by economy rather than any sense of design. And so I would wholeheartedly agree with what Gropius is saying, that it's not about standardising the design, it's about standardising the constituent components. So if the 20th century was about mass production, this century is probably going to be about mass customisation. And the two things that really enable mass customisation to get your head around is what I was talking about before, which is that parametric design, right? Let's do designs that are driven by algorithms and varied by the parameter that we choose. And then let's combine that with digital fabrication. Because in digital fabrication, no matter what the actual fabrication technology is, the computer that's running the machine, it doesn't care how many parts it makes of whatever shape or size. It's just a ones and zeros exercise for that. Whereas mass production depended on semi-skilled workers operating tooling, and they had to be reasonably familiar with the part that they were making. And there was a high cost of switching parts. So we've lost that now. We've gone to digital fabrication. We can make pretty much anything that we can draw, which brings on this new challenge. If you can make anything that you can draw, be careful, because you get your Zaha Hadid approach and everything is wonderful and complex. And so we shift the burden away from manufacturing into the design process, which is why it's so important to have a systemic approach to design. So Lend-Lease opened a facility in 2015 and then spent most of 2016 getting it operationally ready, which is what you do when you set up complex factories. And it's called Design Make. It's out here in Western Sydney. It's out a little bit further, out near Blacktown. And this is a fully digital facility, and it's using CNC to process large formats of engineered timber. So it's one form of digital fabrication. Obviously it's subtractive. That's a pretty mature technology. Everyone's excited about additive fabrication technologies, but they're not yet mature. And as we were setting that business up, we were thinking about what are the products we want to make, how will we make them, how will we make them cost effective, how will we drive the systemic approach to design so we're not back into a bespoke world of making every building unique and therefore having the costs and the waste associated with bespoke buildings. And the references we drew were from aviation, and here you see the fuselage, I think it's of an Airbus, and automotive again, we're seeing the hull of a car, right? What we used to call the chassis, but it's essentially the whole body shell, right? So in those two examples, this one big piece, this one big component, is never outsourced. It's always made by the manufacturer that has the brand on the product. So Airbus's fuselage, Ford or Mercedes or whoever this is, it's their body shell. They never outsource that. Why do they never outsource that? Well, it's the defining component. It's what controls the look of the product. And then there's probably some really pragmatic reasons. Imagine outsourcing that. That's a very big piece of something to make somewhere. So it's not something you really want to make in multiple factories and bring together. They're doing that with all of the things that are readily transportable, like the wings and the trailing edges that are made in Melbourne. But this piece always stays with the manufacturer. So drawing on that logic, we thought we'd do something similar. The other thing we looked at is what's happening in automotive, and they're getting quite sophisticated around this idea of systemisation. So cars for a long time have been built from a bin of parts. We've all had that experience. You know, there's a Lexus and there's a Toyota, and they sort of reference the same body shell and some of the same bin of parts, and then they tune up one to face a different market segment. And that has been reasonably successful for that industry for a while, but even with their highly efficient way of operating, they've looked at how they take it up another gear. And so what Volkswagen did, and then Nissan quickly copied, which is always a sign that they're on the right track, is they rethought the car on this MQB platform. And they said, you know what? We don't need to standardise the body shell, and we don't actually need a bin of parts. We just need to lock down where the complexity is and not vary that. So the highest point of complexity, we will make a standard piece, and everything will hang off that. And the non-complex pieces, we can vary as much as you like. So that, for a car manufacturer, is the engine bay. It's got to deal with the power plant, it's got to deal with all the steering geometry, it's got to deal with all the safety issues of what happens at a high-speed crash. So Volkswagen now has a platform that makes 40 different models of car from, and 4 brands. So Audi, Seat, Skoda and Volkswagen's all running off the same platform. And that engine bay houses electric motors, it houses diesels, hybrids and petrol. They just drop into the same mounting points, the steering geometry all works. And then what you're seeing behind that is really almost back to the old 19th century idea of just coachwork. Make it to look for whatever it has to be for whatever market. So it could be a panel van, it could be a coupe, it can be convertible, it can be a family sedan. It really doesn't matter, because that stuff is very cheap to vary, and we've got the systemic control of the complexity, the 60% of engineering cost that sits in the engine bay. So we've tried to apply that same philosophy to the buildings we're developing using that digital fabrication facility. And so for us, our fuselage or body shell or hull is the building frame. So that's the piece we don't outsource. We want to make that structure. And here you're seeing one of our timber buildings. I think this is International House at Barangaroo. And so we're not interested in making every component of a building. We've been in that part of the supply chain many decades ago, and that's not where we're going back to. Much like those other industries, we're saying, let's control and make this piece, let's outsource all the other pieces and let the industry do that more efficiently than we can. And so we have the emerging idea of frame as a system, and we're on about the 4th design of this, and I won't go through all of them because of it becomes a bit boring after a while, but you kind of get the idea looking at this and then seeing the buildings we've applied it to. It's a column and beam arrangement using engineered timber and CLT floor slabs and CLT lift shafts. So a couple of shots from International House, some of the fit out, a bit more of the fit out. So you're starting to get some quite attractive architecture hanging off what is quite a ruthlessly organised system of parts. And then we've taken that same system and developed it further for the project we're just completing at the moment in Brisbane, 25 King Street. So this has the dubious title of world's tallest timber office building. Everyone's doing world's biggest something in timber at the moment, so you have to qualify it with a number of things like tallest and office. But this building is approaching 21,000 square metres of GFA, and it's using exactly the same system that you saw on the earlier building with a few refinements. Here it is under construction now. Sadly, I haven't got any more recent photos, but if I was to show you another external shot one day after this one, you would see the facade going on to the timber framework. And if you're used to concrete construction or even the steel frame that's going up out there, you know that's not the case normally. You know that the facade is starting some 3, 4 or 5 levels below the concrete structure, and what I've just seen in the US last week, they seem to do the whole concrete structure before they even start the facade. So we're getting this outcome. This is one day after the structural deck, the ceiling you can see in this image is completed, you've got an enclosed facade around it. So when I look at this image here, there's a lot of good points in it and there's some major negatives or opportunities. So the good points is it's a finished structure. There's no propping, there's no temporary works of any sort, there's no formwork to strip, there's no waste formwork to be carted off site, and so the hazards associated with propping and formwork have been removed as well. It's totally dry because as the deck goes down it's got a sealing system between each panel, and so water doesn't run through it, which is another sort of wonderful thing if you've spent much time on construction sites. And of course it's completely buttoned up with a facade. That's where the good stuff ends, because the obvious question is, why is no one working in that floor? Why are the services not being installed? In fact, why haven't they been prefabricated and sitting in racks ready to be raised up onto those ceiling panels? Or at the very least, why has no one preloaded that floor with some packs of what's got to go in? That floor is absolutely barren. So everything's going to come up into this floor via builder's hoists and the usual process, and lugged up stairwells and carried in via toolboxes. I am being deliberately critical of our team that's assembled this, but I know why they haven't done it, because they've been learning how to put a timber building together, and they're thinking that's a huge achievement to do a major timber structure at tallest in the world. And they haven't turned their mind to the next series of opportunities, which is how do we prefabricate everything that follows the structure and the facade. So the system continues, we bring it back to Barangaroo now, we're building the twin of the one that's already complete down there. This is starting construction next month. It's in our factory, I think next week, being processed, and that'll be cut within the next 8 weeks, and then it'll shoot out of the ground hopefully before Christmas. I don't know whether that team on this project is going to pick up what I just talked about and prefabricate the services. I'm not close enough to this project to know what they're doing, but I would certainly hope that it's getting that kind of incremental uplift. Another system, so it's not all about having one system, systems of systems. We've previously developed wall systems that are more appropriate for residential buildings that might be more cellular in plan. And we're using this quite a lot in our US business. And over there we build a lot of stuff on military bases. We have a contract for 50 years to provide on-base accommodation, and we also have a contract to do 5,000 hotel rooms on various bases. And so we've started delivering these hotels in this cross-laminated timber wall frame system. And much like the two frame buildings, they started off as bespoke projects. We're just trying to figure it out. The teams on them are sort of learning. And now what's happening is they're converting those learnings into a very systemic approach. And they're saying to the architect and the engineer, this is the kit. This is what it's built from. These are the spans that work. These are the optimum sizes and details that you need to apply to get the sweet spot extracted from this particular medium. And I like these photos. They came from back around February, March this year. Fort Drum is upstate New York. It's bitterly cold up there. Back around February, this was minus 27 degrees Celsius. This construction crew were the only ones in the region to build all the way through because they weren't working with concrete. They didn't have any issues with curing. They had no wet trades involved whatsoever. All of the stuff, whether it's stud wall or CLT wall, is being prefabricated, of course, and so all they've got to do is be able to grasp a tool with some gloves to be able to put it together. So, you know, productivity maintained all the way through. Still wouldn't want to be doing the job. And we're doing the same stuff in the UK at the moment. This building's in construction now, and the only reason I include this is it's a typical London building, right? It's clad in that interesting yellow clay brick that Londoners are so fond of. And it has to be, because that's what the planners want, it's what the market expects, it fits the context of the city. So you've got traditional brick, but behind it you've got this prefabricated, digitally fabricated timber structure. The challenge, I think, for these teams is, okay, panelise the brick or find ways of doing a brick-like facade that can go as fast as the timber structure. The last one of these buildings we did, the structure went up in something like 8 weeks, 200 apartments, and the brickwork took 6 months to put on. So I'm going to wrap up now, but just where to from here. I use these images here to illustrate a point about how far the industry's got to go. So late last year I was in Sweden. This image here comes from a Swedish pod manufacturer. They make beautiful little bathroom units. State-of-the-art facility. The panels themselves are made of a composite material. There's robots everywhere. There's beautiful Swedish workers in white overalls with gloves on, neatly assembling things. 50% male-female split in the factories. Ergonomics thought about, so that is the ceiling of a bathroom pod. It is sitting on a work table so that the ductwork and wiring is being installed at an ergonomic work height. No one is on a ladder up on top of a box. So you go, well, that's state-of-the-art. That's the best in the world at the moment in terms of making off-site bathroom units. But if we really want to go where other industries have gone, we need to take that bit of ductwork there and make something that looks more like that, which is obviously apart from a car. And why we need to do that is if you analyse this thing here, it's got over 20 components to it, right? It's got a series of bits of tubes that have been cranked around, it's got gaskets, it's got rivets, it's got brackets, it's got screws. That thing down there does exactly the same job, and it's got one part. So this thing was made for cents on the dollar. That thing probably cost over $100 because it had more than one Swedish worker involved in its fabrication and assembly. And yet it's such a benign and small component in the building, but it's a great example of where there's this cost burden and there's this waste in what is state-of-the-art globally at the moment. So I'll finish up there and happy to take the discussion further at a more intimate level. Thanks.